Hey everybody, got a long overdue update, lots to share, lots has happened in the last year. It's all good things, but also I guess they say good things come with time. And one thing that I found out about kind of continuous improvement and development in general is that it is certainly true that it takes longer than you wanted it to, and it's more expensive than you wanted it to. And I'll have some stories to share, even just of the TDU5, and lessons learned, I guess you could say, about that. And so, yeah, let's get into kind of some of the updates for the TDU5, and then I can do a quick walk around with the shop. And so, what I can show here is a pretty close representation of what we'll be shipping. I mean, right now it's looking like end of July. Um, End of July is looking pretty good. I'll say that. It could go depending on how the boards, if there's any delays with those getting fabricated and assembled, which is out of our hands at this point. And so it's just a matter of those final production boards getting delivered, and then we'll be able to ship these out pretty much right away. And so, yeah, here's a pretty close, I would say, finished look at the packaging. And there's some interesting bits about it. It is kind of, it looks very simple, but there's actually a lot of development that has gone in behind the scenes that I haven't shared publicly yet. So that'll be fun to kind of show a little bit more about, specifically with the tooling for the thermoformed packaging. And so this is a pretty common manufacturing method for packaging, is thermoforming, and I'll go show the machine here in a second. But yeah, this is what the more or less the final production unit of the TDU5 will be. I've been messing with this here now for, I mean, close to 6 months, and so I've taken the screen protector, on and off probably a dozen times and stuff. So, that'll look fresher with the new one. But I just wanted to at least show what the finished unit will look like. And you can see here, even with the one I have in hand, it's actually not the production unit. The connectors and the switches are missing, because that's actually part of kind of the story of why this project has been a lot bigger and a lot more challenging than expected. So I had actually started developing the TDU5 enclosure, and then starting to game plan. Actually, I had to spend a couple months just recruiting and talking with probably half a dozen different embedded systems engineers, because most of them said they couldn't do it, or if they were even going to attempt it, they were saying $50,000 type of deal in order to develop something like this from scratch. And so I had spent some time. I selected someone that I really thought was more than qualified for the role, and we came up with this PCB design. And this is probably late 2021 I was designing it, so this would be like Q1 of 2022, where I already had this board made. One of the things that I guess you could say is a learning lesson on my end is the developer that I was working with kind of went MIA on me, to be honest. Whether they had realized that this project was just a bit out of their scope of expertise, I don't know. But yeah, we had I'd gotten to the point of having a board, and I mean, he could design boards, but unfortunately, I just don't think he really knew what was going on the driver's side, which is also a learning lesson on my end, because they're just two very different expertise levels, and both are pretty complicated. And so I had actually $10,000 invested into the development of this board right here, and it was based off of the PIC 32 chip, and this was even during the kind of the chip crisis when I'd gotten these here, so I ended up paying just an exorbitant prices just for these chips, and yeah, now they're just kind of sitting here collecting dust. But yeah, that was one kind of one of the major setbacks, was having to essentially start from scratch, to be honest. So this design was completely scrapped. The money was, invested into that, was completely just sort of gone, and is just a hard lesson that I had to learn on the project management side. So the good thing though is that we're beyond that, and we have a working prototype, and we've gone through 2 iterations of that as well, and now have the production boards ordered, and so they're getting fabricated right now as we speak. So yeah, basically as soon as those boards come in, we will have everything ready to go. So you can see I've got all of the boxes, shipping boxes, then LCD screens, and so we're not taking a product that's already off the shelf. This is just purely an LCD panel, with a ribbon cable, and then our circuit board and our drivers will drive the LEDs and the display, and also it'll be done through USB-C, USB 3.0, which is cool because we can get extra power into there, and so there's no external power needed. And also on top of that, so one of the cool things about the backside is having these 1/4-20 threaded fasteners, because not only do we'll be shipping these universal brackets with it, so depending on whatever wheelbase you have, really doesn't matter, and the height and all that can be completely adjustable, and if you want to remove it, it's just as quick as taking off a 1/4-20 screw. But the unique benefit of having these 1/4-20 brass fasteners is that it'll also work with any standard 1/4-20 camera equipment. So if you wanted to have an articulating arm, you can just screw it on. I'm just doing this because it's the fastest way right now. In this way, you'll be able to mount it however you want. So whether you want it at an angle, whether you want it, as a separate monitor on the side, whether you want it closer to your steering wheel, further away, it's completely universal. It is, once you get all this mounted, it's solid. It's not like it's going to be getting bumped or anything. Yeah, very neat. Now, also going a little bit more into the packaging, what we'll be shipping with is the TDU5. We'll have the universal brackets with the thumb screws, and then a USB-C cable. This here is just an extension cable. I haven't actually gotten the production cables delivered yet. They should be coming in the next week or so. But yeah, it's a nice polyurethane custom cable as well. And the packaging here is neat too, because this was completely designed, and not only is the part built right here in-house, which I'll show shortly, but the mold for it is as well. And the surface finish is pretty much as good as you'll find anywhere. You'll see it's really smudged up because my hands have been greasy. I've actually been greasing the mold because I was playing with it before hitting record here. But yeah, the production units will be nice and clean. We'll have that worked out. One of the cool parts of the design of the mold here is that there's almost like little snap fits, these little undercut parts that you can't do with injection molding, but you can with thermoform molding, is that the TDU5 just kind of pops right in. And since it sits flush in the box, there's really nowhere for it to go. So it'll sit just like this in the box. We'll be able to close it up. And so, yeah, nice solid packaging. I would say one misconception that I really want to get out of the way right away is the material that we're going to be using for pretty much everything going forward. And that is a nylon carbon fiber injection molded material. And I think people sort of assume that since something is not CNC machined out of billet aluminum, they think it's lower quality, or there's less engineering and design that's gone into it, which is a bit silly, kind of funny. But this material is really the future, not just for us, but probably for a lot of product design. I would not be surprised to see more and more in the sim racing industry very, very quickly following the lead of this, because there's so many advantages to it. But not only can you really design in whatever you want, so even stuff like having the logo be kind of like stealth, hidden, in the front of the case itself, since the mold is there's a mold pattern on the injection mold itself, which gives a texture on the A surface of the material here. But then you can also have them polish out the part where the logo is, so then that way in the right light, it's not actually super apparent. For most setups it'll actually be probably completely unrecognizable, but yeah, just kind of a subtle little turn effect there, I guess you could call it. But the big thing about this material is its strength. There's questions about, is this just a plastic enclosure or whatever, and it's not just for this, but for other materials too, or other products in the future going forward. I would like to maybe demonstrate just how durable this is, and so I was thinking of ways to do that. Of course there's like a torsional test where I'll just grab it and try to do my best to make it bend or whatever, which is not possible. There's a sort of like a standard drop test, you could say, which really it's not going to do anything. This material is so hard. So yeah, this material is awesome. It is for sure the future, at least of what turn racing will be doing, and you can throw it on the ground and it pretty much looks exactly new. But yeah, we can keep kind of moving around here, showing some more about the packaging itself. So I've gone through a couple different iterations already of the mold for the packaging. So this was, I think, the first or the second mold. I think we're on the third iteration right now, which I potentially might go to a fourth. I don't know, we'll see. That's one of the cool parts about doing all this in-house is I can make 4 different molds for under $500, which if you're gonna have if you're gonna have something like this machined out of aluminum in the US and then have a smooth finish from like an EDM machine or something, you'll be starting in the 15 to 20,000 range probably. 20 might be high, but 10 to 15, for sure. And then even if you went to China to get something like this made out of aluminum, it's going to be 12 weeks plus 5 to 10,000. And so rather than doing that, there's actually just some new technology really that has made this type of stuff only possible in the last maybe 2 years, maybe 1 year, to be honest. And so the way that these molds are made is actually a Formlabs large format SLA 3D printer. So this is actually 3D printed. And a couple of the cool benefits of that is you can make it extremely strong still, by having, all of the ribbing, but you can choose different types of materials and you get a perfectly smooth surface finish. And so this resin material that it was printed out of is a high temp resin, and the surface finish is pretty incredible. It'll be better than pretty much anything you can get outside of having it professionally CNC machined. Before having gone to the high temp resins, I was actually still making my own molds, and this is actually out of a nylon carbon fiber for the BP2 packaging. And I mean, I would say this is something that really probably I haven't shared well enough, but just being able to make a mold like this in-house was probably a 6-month effort, because I had to build the 3D printing machine that could actually make this, and then I had to kind of tweak the firmware and modify it to dial it in, and then I made the mold, and then you kind of dial in the settings for printing it, and then after that you go through iterations to get the packaging the way that you want functionally. So there's a lot that goes into something like this, and also just the fact of this surface finish is actually something I've never seen done before with just like an at-home FDM 3D printer. This is actually with zero post-processing on the top surface finish there. So that was probably a good month of work just figuring out how to do that. Again, I mean, I might be wrong, but I really have never seen someone achieve a surface finish like that from just a hobbyist FDM 3D printer in nylon carbon fiber as well. But the main reason I wanted to go away from that is the side walls. Just no matter how perfect you can try to get it, which I'll get it in some better light here. But no matter how perfect you can try to get the sidewall, there's still going to be like a bit of a rough edge. And so that's why I wanted to go with the resin 3D printing, which is what we have here. And so, yeah, what I'll do is actually I'll just make a part. Tell people honestly what's going on, since it's a small shop, obviously. Now we have 2 additions to the team here actually in the shop for the first time, which is really exciting. And they've been a huge help with working on assembly and packaging, fulfillment, just keeping things organized. It's been a game changer just for me personally, being able to kind of refocus on rather than spending 40 hours out of my week just doing production, I can refocus that time and energy on stuff like the TDU5, which has really only happened in the last quarter where that was even possible. But yeah, as far as something like this, it's a really big project. There's a reason that we're the only ones so far that have done it. And as far as kind of investment wise, I bet it's close to $100,000 invested into this one product. And it is really just to bring more value than anyone on the market. For I think roughly our pre-order price is $197, and then we'll be going to $217 after our launch. And so that's still unbeatable value for what you're getting. And so yeah, I think it's cool to kind of show a little bit of the behind the scenes, just what goes into just the kind of workflow of assembling the thing. But as far as the development, that really is just another beast of its own, that I could probably do a half-hour video just on that. And yeah, I mean, it really just comes down to a lot of trial and error. And so I think in the future I'll allocate more time for that, I guess you could say. Because even stuff like this here, this is just a bin of actually sample parts. And so, you know, some of these, um, even like right here, so like some of these don't have the mold texture. And I wanted to see what the parts would look like without the mold texture, and then what the parts would look like with the mold texture. And I personally think it looks a lot better with the texture. You know, also one thing that really drives me nuts are fingerprint magnets. And so the thing I really like about this nylon carbon fiber, especially with the texture, is even I have mineral oil on my fingers from greasing up that mold so that it releases the parts. But even with kind of greasy fingers, like there's no marks left on the material itself. You know, so obviously with the LCD screen, that's something I want to figure out still. You know, it's a non-touch panel screen, so it'll be pretty common sense just keeping that clean anyway. But yeah, I mean, there's a bunch of trial and error just with getting the enclosures correct. You know, because there's so much that does go into stuff like this that people don't, you know, recognize. You know, even for the design for the inner side of this part, because, you know, from the outside it looks pretty basic, right? And you know, if this were billet CNC machined, you know, it's honestly pretty easy to machine something like this. But then the amount of design time that goes on the inside that you don't see is a part that is, I think, missed. And you know, you've really got to do it right. And so this was actually completely 100% done by myself. And so designed for injection molding. I'm self-taught in that now. And so this part here, it has a 2 millimeter nominal wall thickness. And then for the ribbing, you're supposed to do a 60% wall thickness on the ribbing as compared to the nominal wall thickness. So if you've got a 2 millimeter wall thickness on the front, you'd go to 1.4, I think, if I'm not mistaken, on the ribbing. And then also making sure that you have all your edges filleted. And then you know, even with the like having these little pockets here for all the LEDs, so that way there's like, you know, zero light bleed between them, which is already tested and actually works out like awesome. So yeah, I mean, that even in itself was, I mean, months, probably 6 months in design, and then another 6 months in actually having the molder, you know, make the mold and then send the first pre-production samples. Because even it goes as far as making sure that the molder has their machine set to the right pressure when the nylon carbon fiber material gets injected in there. And so with a couple of these earlier prototypes, there was a bit of warping, and it comes from, since it's a family mold, and so both the front and rear enclosure are injected at the same time, and then making sure that all of the crevices get filled. So you have to have the pressure in the machine set high enough so that it will evenly fill all of the parts, but not too high, otherwise it will warp the part when it gets ejected. And so that's something that you'll see is a common feature, you know, on any injection molded part. You'll always know, you know, if it is or not, typically, because there's a couple, you know, telltale signs. Ejection pin indents there, and then you know, where is your seam line? And so for us, it's an edge gate, which right here, this little notch by my finger is where the gate is. It's an edge gate, so there's no visible seam line on the part itself. And then there's also a you can see on the outer edge, it is like a lip, I guess, so that the two parts will join a bit more tightly. And that was actually just a lesson that I've learned from the BP2, because I know that there's been issues with the BP2 enclosure, which was my first time ever designing for injection molding, and so there were errors, like admittedly done, at least things that could have been fine-tuned a bit, even though I'd spent I think $750 on paying a mechanical engineer to look over all the files and do like a very thorough sort of investigation of like they call it DFM, designed for manufacturing. And yeah, they never called that stuff out. So just lessons learned by me on the design side. And the TDU5 enclosure is definitely kind of our next generation. This is the direction that we'll be going in the future. As it stands now, I'm using, so everything is actually snap fit. And so even like the sub-assembly to the circuit board is snap fit. And then the LCD panel to the sub-assembly is snap fit. And the way that will get assembled is it just gets dropped in, which is a like press fit. And then you'll have the rear enclosure on the back that will just get dropped in, and then there's 4 screws. And so I think for the next generation, I actually do want to delete those 4 screws out of the assembly. That way there's no fasteners and it's all snap fits, and we'll be able to assemble these and ship them out in under, I mean, they'll be assembled in for sure under 60 seconds, which yeah, is going to be a little bit quicker than what anyone in the competition will do. And I'm even hesitant to share some of that stuff, because these are things that I've spent hundreds of hours, over the last 6 years. It's been thousands of hours learning these lessons. And so, but it's important to show, because it just shows kind of what really goes into, making things. And beyond that, I can kind of show a brief kind of walkthrough of what we got going on, outside of just the TDU5. And so you can see even up here, this is all of the production parts. So you can maybe see these are all labels that Ali and Asha had put together. But the mounting brackets, sub-assemblies, and front and rear enclosures. So we've got enough parts for 1,000 TDU5s, and it's just waiting on those circuit boards. But they're coming, which is exciting. And yeah, that's about it. So I mean, hopefully that was interesting to some of you. It has been quite the year. A lot of lessons learned, and a lot of progress made just behind the scenes that really doesn't get the light of day. But you can see that we're making all the right moves, and that way we can now push towards really scaling in the next year here with of course like the TDU5, but then there's going to be for sure one other main product launch this year, which will be a new steering wheel system, I guess I'll say that. And for this year, that would be probably the main two. I'm working on a formula wheel, but knowing what I know now, it'd be probably not correct to say that it'd be ready by the end of the year. So that'll be probably Q1, Q2 next year, which it's going to be continuing on just the growth. So no two products will be the same. Everything gets improved. A lot of good lessons learned that make it really just to our turn philosophy, which is making products better and making them less expensive. I mean, what else can you want? And so that's why something like the TDU5, that's always the attempt, is how can I make it better than what's on the market, more modular, more features, and also make it less expensive. You know, that's the game, and that's kind of the fun part about it. You get to be creative, solve problems that way, without just shipping production off to offshoring factories. And that's another lesson too, honestly, is just like the difficulty. It's hard to overstate the difficulty of becoming a electronics manufacturer in the US. There's some people I've talked with lately, and we're kind of laughing about it, but it's like almost impossible. I mean, it's nearly impossible. You have to kind of do something like I'm doing, where it is a grind for half a decade to get it to the point where you can design your own hardware, make your own hardware, ship your own hardware direct to consumer. Before, like, I would say 10 years ago, it would probably, not be possible in any scalable way, I guess you could say. Because that's really the goal, is to not just be a small one-man shop, but to actually build a factory. And I don't really use that word super lightly anyway, because what we're doing here is not manufacturing per se, it's mostly assembly. So I'll do all the design, I'll do the rapid prototyping, and then we'll have contract manufacturers, make all of the custom components. And then those custom parts get shipped here as like raw material inventory, and then assembled, QC'd, inventoried, shipped out direct to customer. It's almost impossible, but we're making it work. And hope you guys enjoyed, and I'll try to really push towards doing updates more often. And so I know it's way overdue, and I just really appreciate all of the support that we've got. Overall, customers like really get it. If you just kind of show what's going on, people get it. So the fact that it's a 6-month delay, it's not the end of the world. If anyone wants to cancel the pre-order, like, fully understand, we can refund it that day, and kind of move on. So thank you again, and we'll be back soon.